Alright, welcome to Chapter 2. All of you are off to a good start. Just going to review the first two sections briefly and then move on to the other stuff. So Chapter 2, 3, and 4 extend on the basics of functions you learned in Chapter 1. I think Chapter 1 is probably about the hardest chapter because it covers everything you're going to learn in more detail throughout the rest of the course. So here in Chapter 2 we're going to focus on linear, straight lines, and quadratic functions, parabolas. So the first two sections are about linear functions. So again, both of these should be a review of what you learned in intermediate algebra some time ago, hopefully not too long ago. I'm just going to give an example of a basic linear function, and I like to bike ride, and I've been keeping track of some rides I've been doing here and there. These have been more just kind of for fun, getting in shape kind of rides. And I went for a relatively short ride the other day. I did in about 55 minutes. I went 13 miles. And another ride I did was a bit shorter, 22 minutes, covered 8 miles. Went for a longer ride, 120 minutes, a couple hours, 32 miles. And I was just kind of curious, what my speeds were like. So I calculate average speed there, which would be distance over time. So some relationships that might help here. Talk about speed, which is distance over time. We talked about average rate of change in the last section. That comes up again in the last chapter. That comes up again in this chapter. Distance equals speed times time, or rate times time, another useful one there. So I decided to plug some of these into my TI calculator. A little breeze back here, don't mind that. So to get there, and there's instructions on how to do this in one of the announcements on the main page. Hit the Stat menu, right there. In the Stat menu we choose Edit, so just Enter will work there. And then you can just go into a list and start typing stuff. So I type my 120.32, my 55.13. Let's suppose I went out for another ride, and I went out for 1 hour or 60 minutes. I'm doing minutes here. Enter, and that fixes that in there, and then I can go over to the right and enter the distance I went. So let's say I went 16 miles. So I was pedaling pretty good. Okay. If you want to see those points plotted, then what you would have to do is set up a plot. So where y equals is where we enter functions, like right there. Second y equals is where we plot points. So I'm going to hit Enter to activate plot 1, Enter to turn it on. First option here is scatter plot, which is what I want. And I type my x values in list 1, my times, and my y values, my distances in list 2, and I'm going to choose the big fat mark instead of the plus or the little dot there. A couple ways to graph it from there. You could select a window based on the x's and y's you saw. So x min, let's see, window. So I'm not going to go below 0 minutes, and I have nothing above 180 minutes. I decided to scale by 15. My distances, they're above 0. I had nothing over 50 miles, and I decided to scale by 1. Don't worry about the resolution. So if you have a rough idea of what your window should be, just type it. If you're plotting points and there's a lot of points and you're not exactly sure about the window, you can always go zoom, and then there's a zoom stat option down here somewhere. There it is. And it will look at your data and guess at a window so you can see all of your points. So there's my points, and they roughly line up. I could create a line out of these by picking 2 points. For example, I could pick that first point there. Which one am I on? Oh, I'm up there at the top, 120.32. Let's see how these are in a weird order, so I'll just trace through them. So I could just pick any 2 points here and calculate the line through them. So that'd be one way to proceed. So some formulas you might want to remember for lines: y equals mx plus b is our standard linear function. So all lines that are functions can be written in this form. Other one is y minus y1 equals m times parentheses x minus x1. That's our point slope form for lines. So if you know the slope and you're given a point, then that's what you could use. So for me, if I was going to find a line through 2 points in that graph I just showed you, I would pick the 2 points, find the slope, use one of those points as x1, y1, and then solve for y, and boom, I have a function. So let's see, point slope form. Remember, slope, we usually use the letter m, no good reason for that. There's a lot of rumors out there, but don't believe them. Is rise over run. Rise is your change in y. Triangle delta means change in math over change in x, which we often write as y2 minus y1 over x2 minus x1. Slope y's have to be in the top, x's in the bottom. Points have to line up vertically. Okay? All right. So just for fun, I'll have the calculator find a line through those points. So if I want to have a calculator find a line that kind of goes through those points as close to each point as I can get, there's no line that's going to go through all of them, obviously. I go to the stat menu, and then I go over to calculate a line, and I'm going to choose option 4. Okay, there's a few other options, we're not going to worry about them. And this is the same on the 83, the 80 different versions of 83s and 84s. So selecting that, it's a good idea to tell the calculator where your x's are. So list 1, comma, where are your y's? Mine are in list 2. And then I just hit enter, and then it'll whip that out for me. And so here it says the best line through those points is a slope of about 0.24489, blah, 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 and a y-intercept of about 0.98. Alright. If I want the calculator to enter that line in for me, I could either write those numbers down and retype them, or find yourself an empty slot. And again, all these instructions I wrote up on an announcement on our website. Then you go to variables. Option 5 is statistics. Over to equation, and then I want to enter the regression equation, is what that's called, into line 1. And so it retypes the slope times x plus the y-intercept. And notice the equal sign is highlighted, which means it'll graph that line. And there's the calculator's line of best fit. The linear regression line of best fit, is designed so that the vertical distance from the point, any point to that line, is minimized overall. And if you want to learn more about that, take a couple of statistics courses. Here we're just going to use it and believe it works nice. Alternatively, I could just guess that I was averaging about 15 miles per hour, which would be 15 miles per 60 minutes. 15 over 60 is 1/4. And so I guessed at that y equals 0.25x. So I'm going to enter that one, turn off the other one. Oops, in the wrong spot. Turn off, there we go. And so now it'll just graph my, so you can see, yeah, it looks like I was averaging about 15 miles per hour on those bike rides. Pretty cool, huh? So there's different ways to guess by just looking and making a wild guess, educated guess. You could pick 2 points and find the line through those 2 points, which again you guys are all totally capable of doing, or you could use the linear regression feature. I also have instructions on how to do it on GeoGebra for those of you using GeoGebras. Alright, next topic. Actually, I'm going to pause there and start a new recording for the next topic. So next I'm going to talk about quadratic equations. Over and out.